Hey guys, welcome back. In this lesson, we're going to start our character script file. What I'm going to do first of all is get rid of these by deleting them. Don't worry, they are in our spells folder as prefabs. So inside of our scripts folder, I'm going to create a new C# script, and I'm going to call it character. Now, this is going to be the base class that all of our characters, well, not all of them, we have two different types. We have a party member and an enemy object. They're going to inherit the values and properties from character. So this is going to be the base class for those two types of characters. So we're going to have character, we're also going to have enemy, and then we'll have a party member. Enemy is going to be what our enemies are built on top of, and party member is going to be what our players are built on top of. So let's open up character in Visual Studio. And we're going to treat this similarly to how we treated our spells. What does a character need? Well, first of all, a character is going to need a character name. So a public string character name. We're also going to have some stats. We're going to need our health values. We're going to need our attack power, our defense power, how much mana points do we have, what kind of spells can we cast, that kind of thing. So I want to have a public int called health. And I also want to know how much health we could possibly have. So the health is going to be the current health. I then want to have a public int that's going to be the max health. So I'll have, say, 10 health out of a 20 potential health. That allows us to heal up to that maximum health. Think of a health bar. It's going to have on the left side 0, on the right side the maximum health our character can have. I also want to have a public int for the attack power. So how strong is this character? Whether they're just doing a normal attack or they're casting a spell, that kind of thing. Then a public int that's going to be defense power. How much damage can we reduce incoming damage by? We'll create a very simple formula to help us decide how much our defense affects incoming damage. I also want to know how much mana my character has, so input an int for mana points. And I then want to have a simple list of the possible spells that my character can have. So each character is going to have a different set of spells. Say if we have a dragon character, they'll have fire breath. If we have a range character, they'll have that arrow range spell that we just created, that kind of thing. So I want to make sure that we have a list of spells per character. So I'm going to have a public list, and I'm going to call it spell. Now, if you recall from the Unity 101 course, a list is a generic collection of items. So we can define what type of items go in there by deciding inside the curly brackets here, it's a spell. And we can also dynamically add and remove from this list as we please. May not have to do that for this system, but it's there if we do need to. And I'm going to call it spells. Now we're going to be adding spells to this list from the inspector. And that's going to be all the properties our character is going to need. Now, I'm saying the word property, even though we're just creating some public variables here. Now, if we were using any type of other system where we could actually simply serialize our properties, which would be a property like this, in the inspector to add the values to it, we would be using properties to have anything that is accessed outside of character handled. But in this case, Unity does not serialize properties in the inspector for us or in general, so we have to handle it by using a public field like we're using here. So what does our character need to be able to do? Well, we know they want to be able to cast spells, right? That makes sense. Enemies and characters, or enemies and players, want to be able to cast spells. They also want to be able to take damage. Maybe don't want to, but they need to be able to take damage. And they also want to be able to be healed. Right, so let's start off with those two things, healing and taking damage. So I'll have a public void method here. So publicly accessible because anything outside of character that does damage to it has to be able to use this method. So public void hurt, I'll call it. Now all we need for this is how much damage whatever outside force we're talking about is doing to this character. So I'll just pass in an amount parameter. And then we'll just take that amount and subtract it from the health, right? If we hit 0, we die. But I want to take into account my character's defense power, and I also want to take into account that we cannot go below 0 health. So to do that, first of all, let's first calculate how much damage we are dealt based on our defense level. So I'm going to say int damage amount, just a local variable here. So we can add a random property to the amount of damage we're dealing if you want to do that. You also don't have to. You can make it very consistent if you would like to do that. But I want to have a random property for a random.range 0 to 1. So it's going to range from 0, meaning it does no damage, up to 1, meaning it does all of the potential damage it can do. So multiply that by amount, right? So we're going to say now the amount of damage the spell did is just going to be randomized up to the amount that it was based on. But what I want to do is take the defense into account. So we're going to multiply it by amount minus the character's defense power. Now this simple formula is kind of flawed. So if they were upping their defense in the fight, you'd get to a point where you could do no damage to them. But that would be something you take into account for the balancing of the game. In this case, I'm not too worried about it. So then what I want to do is I want to set the health to be equal to the health that it currently is minus the damage amount, unless that brings me down below 0. If it brings me down below 0, I want to set it to 0. So I want to say health is equal to, and I'm going to use something in the MathF library called max. What this is going to do is give me the upper value of two different values. So if I were to pass in 0 and 1, it would give me 1. 1 is the highest value in that. So I'm going to use this to make sure that I never go below 0, because if the health that we calculated is below 0, 0 is bigger, so it'll select 0. So I'm going to say health minus damage amount or 0, whichever one is larger. So we'll never go below 0. That way I can check to say, if health is equal to 0, then we die. Pretty simple. And our healing method is going to be pretty much the same thing. I'm going to copy this. I'll call it heal. We'll take amount. Now, I'm not sure if we want to randomize this or not, and defense isn't going to matter. We may even want to take and use the character's attack power to change how much it heals, or maybe use the max health potential to change how much it heals. So we could take max health, multiply it by something like that. So that would be if we have more max health, the healing spell will do more than it would normally do. And I want to cast this to an integer, because what we're doing is we're calculating the random amount as 0 or 1, which is an int. Multiplying that by this makes the returning value an int, right? Which is what we're trying to store it in, an int called damage amount. If we did not do that before, if we remove the int here, this is going to calculate a float value, because 0.33, no matter max health being an int or not, is going to return a float value, because if we had 10 max health, multiply that by 0.33, what do you get? You get 3.33. So we have to make sure we convert that back to the closest int. So in that case, it would be 3. And there we go. So damage amount, I'll call it heal amount. Just take that and plop it in there. And I want to add that to the health. So we're taking health and we're adding that amount to it. But I don't want to grab the maximum value compared to 0. I want to grab the minimum value compared to max health. So what's going on here? I'm setting the health to be equal to either max health or health plus the heal amount. And it's going to grab the smallest value. So that way I cannot go over the maximum amount of health a character can have. So let's say we have 10 health and we're healing the player that can have a maximum of 20 health. I don't want the player to have 25 health. So if health plus heal amount is equal to 25, it's going to grab the max health value instead, as it is the smaller of the two values, in this case, setting health to be 20. A very neat and simple, tidy way to restrict the range of values depending on a min or a max value. But for this, I don't care if we have 0 health or not. We're not going to have that if we're healing the character. I also want to have a public void called defend. This is going to be a method that we can call on a character. It's going to increase the defense stat for that character. All it's going to do is we'll say take maybe defense power, and we'll plus equal 2 maybe. Every time we call defend, we add 2 to our defense. Or maybe we add some kind of formula here. So we'll say defense power times 0.33. So we'll add a third of the defense we already have to our defense, and we'll again cast that as an int. So if we have 1, this will be 0.33, so it adds 0 to it. If we have 1 defense, I don't think that would even matter because that character is going to be pretty weak. Don't know if they'll survive long enough to matter. And I want to make sure that I just log this out so we know what's happening. It's not something that we can see in the UI that we're going to have, so I'm just going to say character defense increased. I also want to have another method here that's going to be called whenever we die. So we're going to have up here in hurt, whenever we die, we'll call a method that will take and it will destroy the object. We're going to maybe log something out so we know that somebody died, that kind of thing. So again, a public void die. And I'll go ahead and set this up in health is equal to 0, then we die. So what I want to do is simply destroy this .game object. If we die, just get the character out of the scene. That's how we're going to make sure the character can no longer attack, can no longer be attacked, that kind of thing. So we're going to destroy the character just like that. And I'll debug log format. This allows me to pass in a couple of tokens sprinkled throughout a string that we can then assign values to. And I'll show you how this works. It's very cool. So I'm going to have in my string here, I'm going to have a 0 token. And I'm going to say has died. And what I can do now is after the comma, I can decide what 0 is going to be replaced by. So I can say 0 should be character name. Character name has died. Now you'll notice that in the spell, whenever we log something out, we're just doing a concat here. A simple add this string to this string and then add this string to that string. Then you have a full string. That's a little expensive because you're creating a bunch of new strings and then stringing them together. Whereas in this case, we're just filling in the blanks in a string. Pretty cool. The next thing that our character is going to need the ability to do is to cast a spell. Now, spells have the ability to cast themselves, right? You say spell.cast, give it a target, it'll do its thing. But character needs the ability to know, am I casting a spell? If I am, this is the function, this is the method you call. And this is how you give me the spell that I'm casting, the target I'm casting the spell at, and then it handles communicating with said spell to do whatever it needs to do. So in here, above die, I'll have a public. Now I could have a void and return nothing, but what I want to do is I want this to return something if it was successful. So if I could successfully cast this spell, then I want it to return true. If I could not cast this spell, I want it to return false. Now, why do I want to do that? Because in our spell casting method, I'm going to compare the mana points of our character to the mana cost of the spell. If the cost is higher than the character's mana points, then we can't cast it. We return false, it was not successful. That way I know outside of the cast method whether or not I can successfully cast it. The reason I need to know to do that is because, well, first of all, I want the player to know you failed to cast it, you don't have enough mana, please choose something else. But I also want the simple AI system that we're creating, the enemy system that's handled by the computer. I want to be able to know if I can successfully cast something that I randomly chose. Because if I can't, I have to choose something else. And the system has to know that, right? It's very important that I know false, can't do that, do something else. Move on to something else. So I'm going to return a boolean, so bool, just like that. And I want to call it cast spell. So cast spell, I'm getting an error here because I'm not returning a bool just yet, but I will in a second, so it's fine. I'm going to pass in a spell object as a parameter. We want to know what spell the character is casting, and that's how we can do that. And I also want to know a target character. So what spell I'm casting and what the target for that spell is. So the first thing I want to do in this method is I want to decide, do I have enough mana points to cast it? If I do, great, continue on. So I'm going to say bool. I'm going to create a bool here that's going to be called successful. And it's going to be equal to, what I'm going to do now is compare the amount of mana points that this character has. So this character has mana points, to how much mana that spell that we're trying to cast costs. So I'll say mana points is greater than or equal to spell.mana cost. So greater than or equal to, so if it costs 15 to cast and I have 16, great, we can cast it. If it costs 15 and I have 15, great, we can cast it. But if I have 14, no, we cannot, so it's not successful. So this is going to return a true or false, as this is a comparison, right? If I set it to be equal, that's just assigning successful mana points to spell.mana cost. Don't want to do that. I want to compare it to say, do we have enough? So this will return true or false in a single line here, setting this to be true or false. So down here, what I'll do is I'll return success. But in between these two things, I want to use this information to decide, do I cast a spell or do I not cast the spell? So I'll say if successful, cast a spell. If not successful, don't do anything, just return false. So let's cast the spell. How do we do that? Well, I'm going to create a spell object inside of this conditional that I'm going to call spell to cast. And I'm going to set it to be equal to something. What am I going to set it to be equal to? So what I want to do is I want to actually create this spell object in the world. Now, I don't know yet where I'm getting the spell from. All I know is if something called cast spell, it passed in a spell object. And I want to create that object in the world and send it towards the enemy, dealing damage to it. So how do I do that? Well, I'm going to instantiate the spell object into the world, create an instance of it in our game world. So I'm going to say instantiate. And I'm going to instantiate a spell object, again with the brackets here where we pass in the type for a generic. And then what it needs is the actual object that I'm trying to instantiate. It needs a position and a rotation. So I'm trying to instantiate spell, and the first override for this method takes a transform as a parent. I'm not going to be doing that. I'm simply going to place it at a position in our world. So I'm going to say place it at transform.position. So whenever I cast this spell, it's going to be at the character's position that casted it. The rotation, on the other hand, is going to be quaternion.identity. That gives it the default rotation for that object. Not that important to understand why we're doing this, just understand it gives it the default rotation for that object. And we don't have to define any degrees of rotation or anything like that. Whatever we set it up as when we create the object is what it's going to get. So now that we have created that instance of the object, what it's going to do is in spell, update will be called on that object, which means it's going to be moved towards the target position. Pretty cool, but we created it. We haven't called the cast method on the object just yet. And keep in mind, it's not going to have an error on, say, the next frame because it doesn't have a target position assigned. Because first of all, we're checking for that. But second of all, this is all happening in one single frame, right? We're calling cast spell, it's creating the object, and then we can even go spell to cast dot cast, pass in our target character, and this is all happening on the same frame. So even before update starts to happen, this is going to happen. But if it doesn't, we're checking for that to make sure. Now notice I'm getting an error here because before I said we don't have a character object yet, so I'm just going to use the game object type. So now I want to change this to be character, just like that. And now back in here, we don't have an error. Now either before or after I actually cast this spell, I want to take and subtract the mana cost from the character's mana points. So I'll say mana points minus equals mana cost. Spell dot mana cost. Now if I go back into spell, I can actually use our hurt and heal methods for our spell based on the type. So I'll say target dot hurt if it is an attack. And the amount of damage I want to do is the amount of damage the spell is capable of. So power. And then I'll say target dot heal if it is a heal type. And the amount I want to heal is this spell's power. And of course, the actual character will handle the formula for how much damage or healing is done. But the spell doesn't care about that. All it cares about is telling the character how much it is capable of doing. And the last thing I want to do is I want to quickly set up our party member object because it doesn't do much other than override our die method. And currently our die method cannot be overridden because it is simply a public void die. So I want to say public virtual, which recall from the 101 course, virtual means it can be overridden if you want it to be. So I do want this to be, so in our other characters that inherit from this character-based class, we can do other things. So now let's jump back in and open up party member really quick. Get rid of all this. And we're not going to do anything in this die method just yet, but I'm going to have it there for whenever we need to. So I'm going to have a public override. That's how you say, I know there is a virtual method on the character class that I'm inheriting from called die. I want to take that class and override it with this one. So an override void called die. Now, what it's going to say here is, I don't know what you're talking about. There's not a die method on mono behavior because I'm inheriting from mono behavior. I want to inherit from character. And it's like, oh, okay, I got you. I understand now. And what's cool about this, though, keep in mind, it doesn't just go one parent deep. The character class inherits from mono behavior. So by association, party member is still a mono behavior. So I can still use mono behavior classes and objects and things like that. So that's pretty cool. And what I can do inside of die, let's say now that I've overridden die, if I were to call partymember.die, what it's going to do is only do whatever is inside of this die method. But I also want to do what's inside the base character die. I want to destroy and I want to print. So to do that, all I have to do is say base, and it will refer to character class dot die. So it's going to call the character's die method. And also after that, I can do other things, which we'll do later on. That's going to be it for this lesson. In the next lesson, we're going to set up our enemy class, which again is going to be inheriting from character, and it's going to do some cool stuff that our simple AI system is going to require. My name is Austin, and I will see you in the next lesson.